Hello students, today we are going to start a new chapter, chapter 17, mensuration. As you already know, mensuration deals with plane figures, solid figures, their surface areas, volumes and various application problems related to them. You have already learned such kind of figures in the previous classes like cubes, cuboids and also cylinders. Now in this class, in this chapter, we are going to learn some more about the cylinder, that also especially right circular cylinder. A solid figure formed by revolving a rectangular sheet about any of its sides is known as a right circular cylinder. In a right circular cylinder, if we take the cross sections of the cylinder, each cross section will be a circle and all the cross sections will be congruent to each other. So there is a diagram of a right circular cylinder. If we take the cross sections of this cylinder, each cross section will be a circle, and also all those circles which are taken as the cross sections will be uniform. That means they will have the same radius. So now in the cylinder, if we take the cross sections at both the ends we can consider. The distance between the centers of the cross sections at both the ends, that is known as the height of the cylinder. The radius of each cross section is known as the radius of the cylinder, and a line drawn from the centers of the cross sections on both the ends, that is known as the axis of the cylinder. So the main dimensions of the cylinder are radius and height. Where radius is the radius of each cross section of the cylinder, and height is the distance between the centers of the base and the top and bottom of the cylinder. Now, how to find out the or what are the formula for finding out the surface area and the volume of the cylinder? First of all, let us consider the surface area. When we consider the surface area, there are two kinds of surfaces. One curved surface and two plane surfaces. First of all, let us see how can we obtain the curved surface area of a cylinder. So, curved surface area. The curved surface area can be obtained by multiplying the perimeter of the base with the height of the cylinder. The perimeter of the base can be obtained by 2 pi. You know that the perimeter of the circle can be obtained with the formula 2 pi r into height. That is 2 pi r h. That is the curved surface area of the right circular cylinder. Now, how can we find out the total surface area? Total surface area of cylinder can be obtained by adding both the curved surface area and the sum of the two plane surfaces. So, the curved surface area, total surface area is equal to sum of curved surface area and that is 2 pi r h plus sum of both the plane surfaces. So one plane surface is equal to pi r square, two plane surfaces will be equal to 2 pi r square, that is 2 pi r square. So that is equal to 2 pi r can be common in this plus into h plus r. This is the formula for total surface area of a right circular cylinder. Now, how can we find out the volume of a right circular cylinder? Volume is equal to the volume of a figure for which the uniform whose cross sections are uniform can be obtained by using the formula area of cross section into the height. Here the area of cross section is pi r square. Area of each uniform circle, which are the cross sections, is pi r square into the height, that is pi r square h. Therefore, volume of a right circular cylinder is pi r square h. So, curved surface area is 2 pi r h. Total surface area is 2 pi r into h plus r, and volume is equal to pi r square h. Now let us see how can we get this formula for a hollow right circular cylinder. If we roll a rectangular sheet about any of its sides, we get a hollow right circular cylinder. The picture of a cross section is shown here. The cross section will be two concentric circles, and the thickness of the radius of the inner circle will be small r, radius of the outer circle is capital R. So the thickness of the cross section can be obtained. Thickness of cross section is equal to capital R minus small r. That will be this part. This part will be the thickness of the cross section of the given hollow right circular cylinder, and the area of the cross section. Area of cross section is equal to pi into r square minus r square. Now, in this the external curved surface area. In this we have, this is only a cross section. When we come to the hollow right circular cylinder, we will have two curved surfaces. The external curved surface and also the internal curved surface. So the external curved surface area can be obtained as 2 pi r h. That is in the capital R. The radius of the outer circle of the cross section will be used here. 2 pi r into h. Now the internal curved surface area. Can be obtained by using the inner circle, that is 2 pi r into h. The area of the internal circle, inner circle into height will be the internal curved surface area, and the total surface area will include the external curved surface area, internal curved surface area, and also the surface area of the two concentric circles at both the ends. That means total surface area is equal to the sum of all these surface areas, 2 pi r h plus 2 pi r h. That means two curved surfaces plus 2 into pi r square minus r square. Pi into r square minus r square is the area of one cross section. Like that, two cross sections at both the ends. That means 2 pi into r square minus r square. So this is the formula for total surface area. Now, volume of hollow right circular cylinder can be obtained by using area of cross section. Area of cross section is pi into r square minus r square into height h. Pi into r square minus r square into h. This is the volume of the hollow right circular cylinder. So these are the various formulae regarding with the hollow right circular cylinder. Now let us solve exercise 17.1. Here I am going to solve question number 2. An electric geyser is cylindrical in shape, having a diameter of 35 cm and height 1.2 meter. Neglecting the thickness of its walls, calculate its outer lateral surface area, its capacity in liters. So here the diameter of the geyser is given. So let us write diameter of geyser is equal to 35 centimeter. So from this we can find out the radius. Radius r is equal to 17.5 centimeter. Now the height of the geyser is given as 1.2 meter. Height of geyser is equal to 1.2 meter. That also we have to convert it into centimeter. That is equal to, that is h is equal to 120 centimeter. Now we have to find out the outer lateral surface area. First one, outer lateral here it is given neglecting the thickness of the walls. That is, thickness is very less, we don't have to consider it. So inner lateral surface area or outer lateral surface area, whatever it is, it will be same. We can use the same R for that. That is equal to 2 pi R H. That is equal to 2 into 22 by 7. Here in all these questions it is given. Take the value of pi as 22 by 7 unless mentioned otherwise. If it is mentioned that the value of pi is 3.14, you have to take it as 3.14. Otherwise, we can take as 22 by 7 itself. So 2 into 22 by 7 into radius. Radius is 17.5 into height. That is 120 centimeter. Now that is equal to here 7 and 17.5 you can cut. Here we can write 5. Here we can write 2. 3.5 goes 2 times in 7 and 5 times in 17.5. Now here this 2 and this 2 you can cut. Now 22 into 5. 110 into 120. That is equal to 13,200 centimeter square. So this can also be written as 1.82 meter square. So that is the outer lateral surface area. Now we have to find out the volume. Volume is equal to, we have to find out the capacity in liters. So for finding out the capacity, we have to find out the volume. So second is, volume is equal to pi r square h. That is equal to 22 by 7 into 17.5 into 17.5 into 120. That is equal to 11 into 5 into 17.5 into 120. By calculating this, we get 1,15,500 centimeter cube. Now we know that 1 liter is equal to 1,000 centimeter cube. 1 liter is equal to 1,000 centimeter cube. That is equal to, so in order to find out the quantity in liters, we have to divide centimeter cube by 1000. So we get 115.5 liters. This is the capacity of the vessel. Question number 6. A road roller in the shape of a cylinder has a diameter 0.7 meter and its width is 1.2 meter. Find least number of revolutions that the roller must make in order to level a playground of size 120 meter by 44 meter. In this case, we have to find out the outer lateral surface area of the road roller only. So for that, we have the diameter here. So we can write diameter of the roller is equal to 0.7 meter. That means the radius R is equal to 0.35 meter. Dividing 0.7 by 2, we get 0.35 meter. And here the width of the road roller is given. That means we can take the height. So height in bracket we can write width, but we take it as the height of the cylinder here. Height h is equal to 1.2 meter. We have to find out the outer lateral surface area. Outer lateral surface area. that is equal to 2 pi r h, that is equal to 2 into 22 by 7 into radius is 0.35 into 1.2, that is equal to here 0.35 and 7 cutting we get 20. Here we can get 22 by 10, that is 2.2 into 1.2. Multiplying this, we get 2.64 meter square. This is the outer lateral surface area or the area by which the roller rolls through the ground. Now we have given the dimensions of the ground, that is 120 meter by 44 meter. So area of the playground is equal to 120 into 44. Multiply 120 into 44, we get 5280 meter square. To find out the number of revolutions, we have to divide the area of the playground by the lateral surface area of the roller. So we can write number of revolutions is equal to area of the playground divided by outer lateral surface area of roller. Now that is equal to area of the playground is 5280 divided by 2.64. Dividing these two, we get 2000. So it takes 2000 revolutions to level the ground. Now question number 11. The barrel of a fountain pen, cylindrical in shape, is 7 cm long and 5 mm in diameter. A full barrel of ink in the pen will be used up when writing 310 words on an average. How many words would use up a bottle of ink containing 1/5 of a liter? Answer correct to the nearest 100 words. So here the dimensions of the cylindrical barrel is given, 7 cm long and 5 mm in diameter. So diameter of the barrel is equal to to 5 millimeter. Radius is equal to radius R is equal to 2.5 millimeter and the height is H is equal to 7 centimeter or 70 millimeter. So first of all we have to find out the volume of the barrel, that is the capacity of the barrel. So volume is equal to 5 r square h. It is equal to 22 by 7 into r square, 2.5 into 2.5 into 7. 1375 millimeter cube, that is equal to 1.375 centimeter cube. So this is the capacity of the barrel. Now we can write it in terms of liter because the volume of the ink is given in liters, that is 1/5 of a liter. So here if we convert it into liter, we know that 1 liter is equal to 1000 centimeter cube. So this is equal to, we can divide it by 1000 for converting into liter, that is 1 1.375 divided by 1000 liters, that is equal to 0.001375 liters, because 1 liter is equal to 1000 centimeter cube. Now it is given that in writing 310 words, a full barrel of ink is used. That means by using this much quantity of ink, we can write 310 words. So the number of words written using .001375 liter of ink is equal to 310. Now, by using the unitary method, we can write number of words written using 1 liter of ink is equal to 310 divided by 0.001375. Now, again by using unitary method, number of words written using, here it is given 1/5 of a liter. 1/5 of a liter means 0.2 liter of ink is equal to 310 into 0.2 divided by 0.001375. So by calculating this, we can get the number of words which are written using 0.2 or 1/5 of a liter of ink. So in order to calculate this, we have to multiply both numerator and denominator by 10 lakhs, because there are 6 digits after decimal in the denominator. So that is equal to 310 into 0.2 into 10 lakh divided by, here the decimal point will be eliminated, so it will be written as 1375. Now by calculating this, we get, so here we can cancel by 5, here we get 275 and here we get 2 lakhs. Again by 5 we get 55 here, here we get 40,000. Again by 5 we get 11 and here we get 8,000. So here it is simplified, that is equal to 310 into 0.2, that is 62. 62 into 8,000 divided by 11. 45,090 approx. There will be decimal points, we don't have to take that, because we are only asked to find out the number of words in nearest to 100 words. So here we can take it as approx, and we are rounding it to up to hundreds, we get 45,100 words. Now question number 22. A cylindrical roller made of iron is 2 meter long. Its inner diameter is 35 centimeter and the thickness is 7 centimeter all round. Find the weight of the roller in kg if 1 centimeter cube of iron weighs 8 grams. So here we have to apply the formula for a hollow cylinder. We have to find out the volume of a hollow cylinder. This roller is in the model of a hollow cylinder. So first of all, we have to find out the inner and outer radius. First of all, the inner diameter is given. Inner diameter is equal to 35 centimeter. So the inner radius, small r, will be equal to 17.5 centimeter. Now therefore the outer radius, capital R, will be equal to, the thickness is whole round. So we have to add the thickness to find out the outer radius. 17.5 plus 7, that is equal to 24.5 centimeter. And now the length is given, that is 2 meter. That means height. We can take the length as height. Height h is equal to 2 meter, or that is equal to 200 centimeter. Now we know that volume of a hollow right circular cylinder is equal to pi into r square minus r square into h. That is equal to 22 by 7 into r square. 24, capital R is 24.5. 24.5 square minus small r square 17.5 square into 200. That is equal to 22 by 7. See, this 24.5 square minus 17.5 square can be written in the form of a plus b into a minus 2 for convenience. So here I am writing 200 into a plus b. 24.5 plus 17.5 into 24.5 minus 17.5. You can also find out the square and subtract. Here I am doing in this method. So 22 by 7 into 200 into 24.5 plus 17.5 is 42 into 24.5 minus 17.5 is 7. So here 7 and 7 will be cut. Remaining 22 into 200 into 42. That is equal to 1,84,800 centimeter cube. So this is the volume of the hollow right circular cylinder, or volume of the roller. Now we have to find out the weight of the roller. Here it is given that 1 centimeter cube of roller measures 8 grams. Therefore we have to multiply the given volume by 8. So we can write weight of 1 centimeter cube of metal is equal to 8 grams. So we have to multiply the given volume into 8 to find out the weight of the roller. Weight of roller is equal to weight of the volume of the roller into 8. That is equal to 0, 8 0 0, 8 0 0, 8 8 64, 8 4 32 plus 6, 38, 64 plus 3, 67, 40. So this is the weight of the roller in grams. For finding out this weight in kilograms, we have to divide it by 1000. That is 14,478.4 kilograms.